Wastewater Management in Urban and Industrial Areas. Lesson 5. Measurement and Physical or Chemical Treatment of Municipal Wastewater Pollutants.
Municipal wastewater has various types of pollutants, and their concentration vary by individual matters. Thus, it is almost impossible to analyze these tons of pollutants individually and measuring their concentration. Thus, it is necessary to indirectly show the amount of pollutants through a comprehensive measurement index, which is based on the integrative characteristics of pollutants. How do we do that? Let's learn about it by examining typical indexes that can measure the pollution level of municipal wastewater this time. And we will also learn about what methods are used to eliminate these pollutants.
Through this lesson, you will be able to explain the analysis method of pollutants included in municipal wastewater, as well as the physical and chemical treatment methods of municipal wastewater. Now, let us begin.
1. Analysis methods of municipal wastewater pollutants.
Municipal wastewater contains various types of pollutants in different concentrations. Analyzing and measuring these hundreds and thousands of one by one individually requires so much time and effort, and their analysis is very difficult itself. Thus, in terms of general municipal wastewater management, the comprehensive analysis of such pollutants according to their physical, chemical, and biological characteristics is performed. An example is measuring the biochemical oxygen demand, chemical oxygen demand, total nitrogen, total phosphorus, etc. of wastewater. For example, BOD analysis can measure the concentration biodegradable organic matters among the various pollutants of wastewater. To regulate the water quality of treated water discharged after wastewater processing, most countries have set such comprehensive index as a regulatory standard item. Based on the water quality of effluent from public wastewater disposal facilities, South Korea sets suspended solids, BOD, COD, TN, TP, total number of colitis germs, and ecotoxicological value. This lesson will focus on learning about solids, BOD, and COD analysis method, which are the most basic of these indexes.
Depending on their size and physical characteristics, various solid matters included in municipal wastewater can be classified into total solids, total volatile solids, total fixed solids, total suspended solids, volatile suspended solids, fixed suspended solids, total dissolved solids, volatile dissolved solids, and fixed dissolved solids.
Here, the size means whether wastewater can pass through glass fiber filter that has a pore size of 0.45 to 2 micrometers, and physical characteristics means whether it is volatilized at 500 degrees Celsius. Most of these solids are eliminated during wastewater disposal when going through screening, grit chamber, and the primary sedimentation basin, and some solids flowing into a biological reactor can be eliminated biologically through hydrolysis, according to the operating condition of reactor. The solid mass for each item is the value after measuring the weight of solid selected by analysis and dividing that weight into the sample amount of wastewater. Wastewater with relatively higher concentration of volatile solids than residual solids can be said to include more organic solid pollutants than inorganic solid pollutants. That means it is wastewater that has more content of organic solids than inorganic solids. But we cannot tell only through solid concentration analysis whether all these solid organic matters can be degraded biologically or are difficult to be degraded. For wastewater and surface water, BOD is used the most commonly as the index of organic pollutants. Among wastewater, organic matters are needed for the metabolism of microorganisms, which consume dissolved oxygen in water during this process. This is the same as us consuming food, breathing, producing the energy we need for physical activities at the same time, and synthesizing our body using various organic matters in food. That is, organic matters in wastewater are consumed as food of microorganisms and are used to produce energy needed for metabolism and synthesize cells. Also, the more amount of organic matters in wastewater is, the more there is the amount of oxygen consumed while microorganisms breathe. Thus, BOD can indirectly measure and quantify the amount of oxygen consumed when microorganisms use wastewater organic matters. Such BOD analysis method can only measure the amount of biological degradable organic matters in wastewater. Its concept is shown on the screen. To summarize, BOD is the same as the entire amount of dissolved oxygen consumed while microorganisms intake organic matters to produce energy and synthesize new microorganisms. In addition, the amount of oxygen consumed while the mixed liquid of wastewater sample and microorganisms are cultured for 5 days at 20 degrees Celsius is measured as standard and is shown as BOD5 to clarify this fact. It would be BOD3 if they are cultured only for 3 days, right? While culturing them for 5 days, about 60 to 70% of the entirely biological degradable organic matters from wastewater are degraded. The period of culturing will become very long to find a BOD value near 100%. Since there is a way to use time and effort efficiently and a mathematical statistical methodology to measure the original true value from the BOD5 value, in general, it is rational enough to suggest BOD5. However, since BOD measures pollutants based on microorganisms' metabolism, it has various limitations. First, it can only measure biologically degradable organic matters. And second, it has a huge error depending on the experiment environment, such as temperature, skill of experimenter, and the types of microorganisms seeded. Third, pre-processing is needed to eliminate toxic substances when measuring the BOD of wastewater that includes toxic pollutants, because they influence the activities of microorganisms. And fourth, an action must be taken to minimize the impact of nitrifying microorganisms. Lastly, BOD takes a very long time to measure pollutants. Despite of these limitations, the biochemical BOD measurement result tells the oxygen demand needed for the biological degradation of organic matters. So it is necessary for the design of wastewater disposal plant that is based on biological treatment method. Also, many countries still use the BOD method as an index to judge whether the water quality of effluent after wastewater disposal satisfies the legal regulation. So it is very important to understand and learn the meaning and measurement method of BOD well. To be more accurate, BOD measures the amount of biologically degradable carbon organic pollutants among pollutants in wastewater. So it is also called carbonaceous biochemical oxygen demand. In other words, the amount of oxygen consumed by microorganisms that use carbon organic pollutants for metabolism is measured. However, some microorganisms use non-carbon inorganic matters, such as ammonia, among wastewater for metabolism. Ammonia nitrogen is converted into nitrite by such microbial action, and nitrite is converted into nitrate. This is called the nitrification of ammonia nitrogen. Oxygen is also consumed during this nitrification process, and oxygen demand due to nitrification is distinguished from CBOD and is called nitrogenous biochemical oxygen demand. In general, municipal wastewater not only has carbon organic pollutants, but also a lot of ammonia nitrogen. Ammonia nitrogen can occur during the hydrolysis process of protein or directly results from excreta. Microorganisms that use ammonia nitrogen for metabolism has a very slow growth speed in a general condition, and it is known that nitrification occurs more actively after all carbon organic pollutants are degraded. Therefore, when measuring the BOD of municipal wastewater, CBOD is measured first, followed by NBOD. It is known that only CBOD is usually measured for 5 days or less of culture, but CBOD and NBOD can be measured at the same time for 5 days or less of culture, depending on the amount of pollutants in wastewater and the characteristics of seeding microorganisms. Legal regulations on general wastewater effluent is on CBOD, so drugs inhibiting the nitrification process are sometimes injected not to measure NBOD. BOD measurement is a method based on microbial activities that measures the amount of biologically degradable organic matters. However, wastewater includes a lot of organic pollutants that are difficult to be biologically degraded, so COD method is useful to quantify these pollutants. When measuring the amount of pollutants in wastewater, COD has the same principle as BOD in that it measures the amount of oxygen consumed during the oxidation of organic pollutants into inorganic matters such as CO2 and H2O, indirectly showing the amount of organic pollutants. However, the difference is that while BOD observes the amount of oxygen required by microorganisms, COD measures the amount of oxidizer consumed when artificial oxidizer is put instead of microorganisms so that wastewater pollutants are oxidized into inorganic matters as a result. Then, the greater the amount of pollutants is, the greater the amount of oxidizer consumed during oxidation reaction, right? The measured amount of oxidizer consumed can be converted into the equivalent amount of oxygen consumed, which is called COD. Usually, dichromic acid or permanganic acid are used as oxidizers, and Korean or Japanese standard test laws use permanganic acid as oxidizer, while the US and Europe use dichromic acid. To distinguish each case, manganese and chromium under COD are used as suffixes. COD manganese is COD measurement oxidizer that uses permanganic acid, and COD chromium uses dichromic acid. The oxidation ability of dichromic acid is stronger than that of permanganic acid, and thus COD chromium value is measured higher than COD manganese value. Also, since COD can oxidize all biologically degradable organic matters and non-degradable organic matters, so a higher value of oxygen demand than BOD value is measured regardless of oxidizer types. What advantages does COD measurement have compared to BOD? First, like lignin, it can oxidize organic pollutants that are difficult to be biologically oxidized. In other words, it can measure the oxygen demand of organic matters that are not biologically degradable. Second, if pollutants can be oxidized by oxidizer regardless of their toxicity, their oxygen demand can be measured. And third, the measurement time is very short compared to the BOD method. While BOD takes at least 5 days, COD can measure within 2 to 3 hours. Fourth, COD value does not include oxygen demand needed for the nitrification of nitrogenous organic matters, such as ammonia, etc., in wastewater. However, there are also disadvantages. To measure the amount of pollutants in wastewater, chemical matters, such as artificial oxidizer, and strongly acidic matters are used, and the waste fluid formed after COD measurement becomes another source of water pollution. Thus, commercialized COD measurement kits are making continuous efforts to develop a product that can minimize the generation of waste fluid polluting water quality and make accurate measurements. However, since wastewater has various pollutants such as nitrogen, phosphorus, inorganic metal ingredients, pathogens, etc., measurement methods such as SS, BOD, COD, and TOC cannot quantify these pollutants. As for nitrogen, general municipal wastewater contains 10 milligrams to 50 milligrams per liter of nitrogen and is measured by largely classifying into total nitrogen, total Kjeldahl nitrogen, nitrate, etc. There are different measurement methods for each classification, and detailed measurement follows standardized method for each country. Commercialized measurement tools provided in kit form, similarly to BOD and COD, are used, and automated analyzers are also used to measure TOC. As for phosphorus, 1 mg to 5 mg per liter it exists in municipal wastewater, in a form of orthophosphate, polyphosphate, organic phosphate, etc. Here, orthophosphate can be measured by chemically combining it with phosphate to form complex compounds, adding a matter such as ammonium molybdate that creates a bluish color, and by measuring the coloring degree using chromaticity method. Polyphosphate and organic phosphate is measured using the same method by converting them into orthophosphate through heat and acid matters. Furthermore, to identify the amount and characteristics of pollutants in wastewater, color, turbidity, odor, metal ion concentration, hardness, alkalinity, hydrogen ion concentration, conductivity, etc. are measured.
Pop quiz. Please read the following question and select O if it is correct and X if it is wrong. Physical treatment method.
The physical treatment of municipal wastewater is usually separating non-soluble matters in wastewater from water. By eliminating huge impure matters or small solids or some dissolved matters, it aims to reduce the loading rate of organic matter in influent as much as possible. Through this, it can also increase the efficiency of secondary processing that includes the later biological treatment process. Such physical treatment method eliminates pollutants from wastewater using physical properties, such as the proportion of pollutants and particle size, and each physical treatment method is called physical unit process. In municipal wastewater disposal, physical unit process is applied to primary treatment, such as pretreatment, and primary sedimentation. It is also used as secondary sedimentation during biological secondary processing. Also, physical unit process, such as absorption or filtration, is applied to have additional processing for reusing treated water discharged from secondary sedimentation as wastewater. Then let's learn about what types of physical unit process there are. First, screen device aims to eliminate floating impure matters in wastewater, reduce the load on follow-up treatment facility, and prevent pipes from blocking by impure matters. Recently, a mechanical elimination device automatically eliminates matters on the screen using the attached screen, and filtered solids are collected and treated by hygienic landfill or incineration. The minimum flow velocity of wastewater flowing into screen is 0.45 meters per second, or higher in general, and the flow velocity passing through the bars of screen is designed between 0.6 meters per second to 1 meter per second. Second, grit chamber is a unit process used to prevent the disruption of pump operation and the shutdown of and management by pebbles, sand, metals, other inorganic matters, etc., existing in municipal wastewater, and to increase the efficiency of sludge processing. It controls the flow velocity of wastewater and mainly eliminates heavy inorganic matters that can have sedimentation by specific gravity. The targets for sedimentation and matters with specific gravity higher than 2.65 and diameter longer than 0.2 millimeters. Third, equalization tank is installed when there is a severe change in the equalization tank of wastewater flowing in and its concentration. It collects and undertows the wastewater flowing in from various wastewater pipes, and equalizes the concentration of wastewater pollutants, such as BOD and SS, etc., sent to secondary biological treatment process through mechanical mixing. In addition, Equalization tank is generally installed after a screen or grit chamber and supplies almost consistent flux and concentration to the follow-up process, increasing the overall efficiency of pollutant treatment. When using an equalization tank, the elimination rate of solid matters in primary sedimentation is increased by from 20% to 40%. Fourth, mixing completely mixes one matters with another matter. During municipal wastewater disposal, mixing is used to evenly distribute colloidal matters and dissolved matters in wastewater, or to increase the efficiency of chemical cohesion processing and heat transfer efficiency. Mixing process is used during the unit processing of equalization tank, biological reactor, absorption, chemical cohesion, etc., rather than used independently. Fifth, sedimentation is a unit process of eliminating sedimentary solids that sinks by gravity among floating matters in wastewater. This is applied to grit chamber. Remove particulate matters from wastewater in primary sedimentation basin, separate cleanly treated water from microorganisms in secondary sedimentation after going through biological reactor to produce the final effluent. When chemical cohesion is used, sedimentation is also used to eliminate flux. To put more easily, sedimentation process puts mixed liquid in a huge tank called sedimentation or water tank and makes substances contained in mixed liquid sink by gravitational action. Sixth, flotation is one of the unit processes to separate solid or liquid particles included in mixed liquid. Its function and purpose are the same as those of sedimentation. However, flotation injects a very small size of air bubbles into mixed liquid, and these air bubbles attach to the surface of oil, relatively low specific gravity of SS, microorganism residues, etc., in wastewater. By lowering the specific gravity of pollutants than water as a result, this method makes the particles float on the water surface and separate, eliminate them from surface. In other words, flotation uses the buoyancy of air bubbles to efficiently eliminate the particles with a very slow sinking speed in gravity sedimentation in a very short time. It also uses chemicals together to help this, which change pollutants into a favorable surface property or structure to adsorb or collect air bubbles. Flotation method is applied usually to eliminate recent algal bloom or microalgae in lakes or ponds. Seventh, filtration is a process of eliminating fine particles that are not eliminated during sedimentation after making them pass through porous layer. For porous filter, materials such as sand, anthracite, diatomite, and minutely weaved fabric are used. Also, for eliminating pollutants by filtration, particles greater than filter pores are filtered without passing through the pores, stick to the filter surface, or become sediment. They can be eliminated by chemical absorption on filter surface or inside the pore, or are eliminated by physically sticking to filter by electrostatic force or manpower. If there is a biofilm on the filter surface or inside the pore, pollutants can be eliminated by microbial action. Eighth, membrane process is similar to the previously examined filtration method, but membrane can eliminate pollutants with much smaller size than filtration. Also, unlike how regular filtration usually eliminates solids from mixed liquid, membrane process selectively separates a certain solute or solvent from mixed matters, in which different phases of matters are mixed regardless of liquid, solid, and gas. To separate mixed matters, the permeability of the membrane of individual matters should be different. For example, if it is easy for water to pass through membrane than colloid particles when treating colloidal pollutants from municipal wastewater by membrane process, a relatively greater amount of water than colloid particles pass through membrane. Then, clean treated water with colloid particles eliminated can be produced. Ninth, Making adsorbent stick to adsorbate physically and chemically during water purification or wastewater disposal process is called absorption. Among wastewater pollutants are adsorbates and matters such as activate carbon or typical adsorbents. Absorption is often used to eliminate chemical matters that are not biologically degradable, very small amount of toxic substances, drugs and medical supplies, residual matters, endocrine disruptors, etc., and occurs when the combination power between adsorbent and adsorbate is greater than that of wastewater and adsorbate. When eliminating wastewater pollutants through absorption, there is a limit to the capacity of absorbent to absorb pollutants as the absorption time goes by, and there is no more absorption when it exceeds the maximum allowance level, which is called breakthrough point. When this breakthrough point is passed, pollutants are not eliminated and are discharged in treated water. So it is essential to recover the original ability of absorbent by eliminate absorbed pollutants before reaching the breakthrough point.
3. Chemical treatment method.
The chemical treatment of municipal wastewater means the removal of pollutants through chemical reaction. Such treatment processing process is called chemical unit processing. In municipal wastewater, chemical treatment process is applied to mainly remove nitrogen and phosphorus, which are nutritive salts. Typical chemical unit processing methods are chemical cohesion or pH adjustment, neutralization, oxidation reduction, ion exchange, etc. Chemical unit processing shows clear effects and high processing efficiency at a theoretically predictable level. However, its disadvantage is that it requires adding chemical matters to induce chemical reaction. Then, let's take a look at what are in chemical unit processing. First, it is chemical sedimentation. This method changes the surface of dissolved and floating matters, causing the matters to contact and combine with each other to form floc, which rises in proportion and sinks due to sedimentation by gravity. It has been used when the concentration of municipal wastewater changes severely or as a complementary means of sedimentation processing, and mainly aims to eliminate particulate solids and colloidal matters. It has recently been used to eliminate nutritive salts and organic compounds, such as nitrogen and phosphorus, and can eliminate 80 to 90% of total floating matters, 40 to 70% of BOD, 30 to 60% of COD, and 80 to 90% of bacteria by sedimentation. Chemicals used for wastewater treatment are inorganic coagulants, such as ferric chloride, ferric sulfate, aluminum chloride, potassium hydroxide, and aluminum sulfate, potassium chloride, and high-molecule organic coagulants are in some cases. The second method is neutralization. This means that acid and base react with each other and create salt and water. It adjusts the pH of treated water to be close to neutral by putting chemicals of opposite property into acid or alkali wastewater. Instead of balancing pH to exactly 7.0, the level is adjusted to maintain between 6.5 to 7.5. In pH control methods, there are limestone layer, slurry limestone neutralization, caustic soda neutralization, sodium carbonate neutralization, and ammonia neutralization. The types of neutralizers are neutralizers applied to acid wastewater, which include slaked lime, caustic soda, soda ash, limestone, and quicklime, and neutralizers applied to alkaline wastewater include sulfuric acid, hydrochloric acid, carbon dioxide gas, and sulfur dioxide gas. The third is oxidation and reduction. Oxidation means, in terms of chemical reaction, combining oxygen to compounds or elements or eliminating hydrogen from compounds. To be more accurate, a compound or element loses its electron. In contrast, reduction means a surface chemical reaction losing oxygen or gaining hydrogen. This means taking an electron from another compound or element to bring to itself. Here, a matter that reduces itself by oxidizing another is oxidizer, and the opposite is called reducer. Oxidation processing is a reaction that injects oxidizer to completely oxidize organic matters in wastewater to turn them into inorganic matters or harmless matters, or oxidizes water-soluble metal ion to turn them into non-water-soluble matters. Main oxidizers include ozone, chlorine, iron, UV, etc. On the other hand, reduction processing is a method of reducing harmful matters, toxic substances, and strongly oxidative matters in wastewater to make them harmless. Reduction processing is rarely used only by itself. Matters to be eliminated sediment through neutralization after reduction reaction to eliminate them. Main reducers include sulfuric acid, ferrous salt, sulfite, copper ion, etc. The fourth is ion exchange. This means the exchange of ions in dissolved ion matters and ion exchange resin in water. For municipal wastewater, rather than directly applying ion exchange to influent, it is used on treated water that is discharged through the final sedimentation for using wastewater or for specific purposes to gain a high quality of effluent. Anion exchange resin is used to remove anion from wastewater, while cation exchange resin is used to eliminate cation. The cation exchange resin whose exchangeability is exhausted regenerates its original ability by passing through sulfuric acid solution or hydrochloric acid solution, and anion exchange resin regenerates by passing through sodium hydroxide solution. In the ion exchange method, the processing efficiency drops when there are suspended solids and organic matters in wastewater. Thus, pre-processing, such as sand filtration and activated carbon, is necessary before ion exchange for wastewater having these matters. The method of eliminating ionic pollutants using ion exchange resin can collect useful metals from wastewater and make wastewater harmless, but it is difficult to be applied if wastewater contains a high concentration of ionic matters. Thus, it is mainly used to remove a relatively low concentration of ionic pollutants. This method is used more for industrial wastewater processing that includes zinc, copper, chrome, hydrochloric acid, etc., rather than in general processing of municipal wastewater.
Quiz! Let's check what we've learned through a quiz. 3 questions will be given, and you will have 2 chances. Then let's start. Summary. Let's review and summarize what we've learned so far.
We learned about measurement and physical or chemical treatment of municipal wastewater pollutants this time. We will learn about economic principles of wastewater management next time. Thank you very much, everyone.